Hi class, welcome back. So we are on 3.4 and I hope that you're enjoying derivative. I actually enjoyed it a lot. I just thought that's like a playing video game, and then when I get the right answer it feels so good. So I hope you're enjoying it too. Just keep playing with me with the homework. So today we are going to learn about chain rule. What is a chain rule? Well, I'm going to actually explain the format before. Did you guys notice when we use the product rule? Product rules are when we have the functions multiplied together. So for me, I just circle around and then to see that where the shape of the function or how the functions are composed. So if we have this shape of a multiplication, we use a product rule. And if it's a division, then you can use a quotient, or you could use as a negative power and then apply product rule. Sometimes this way could be easier, sometimes that way is easier, just depending on. And then when it's a chain rule, when the functions are composed inside of the inside, like this. So if you look at here, you have an f function outside and g function inside. So first, before you are going to approach this one, I want to see that if you can notice with me, what is the function usually look like. So look at those examples. If you can circle with me how many functions are composed, and then I will explain how derivative works here. And this one, I see the outside function and inside function. I have linear and exponent. And we keep looking at it, this function and that function. Okay. I want you to also try this one. How many you see it? So circle quickly before you look at mine. So did you notice? So if you actually the shape of this circle, how functions are composed to each other, you see that which one you could apply. That's how I learned, and then I actually liked it. For me, this one is like a peeling the onions. So that's how you can find all the functions. If you enjoy it, just you can do all the rest of them too. So now, how we are going to take a derivative of function composed inside of one of the function. Then I want to see if you can see here what is the g function. G function here is going to be g, input is x. And do you guys see now what is the outside function? That's the f function with input is a g, right? So I want you to see that if we have f over x, if I take a derivative, we have a df dx. So think about our rise over run as a slope, right? Y over x, so df over dx, that's the derivative. Then how about this one? How are we gonna write the derivative of this one? Listen carefully, it's gonna be complicated, okay? And then actually it applies in coding. I saw it in Python, lesson 4. So this one is going to be similar ones in Python. The g dx, if you take a derivative, and if you take a derivative, this is going to be, as you guess, df dg. Have to be very careful. Have to be very careful. This one becomes df dg. And from here, how we are going to compose this? We have to see that we cannot take a derivative right away. So I'm basically taking derivative df over dx. Do you see the input is x, output is do you see the input is x and output is f? So from here, I cannot take a derivative directly because f input is actually g. So I'm going to use some trick. This one actually I can do this way legally. Do you see why? Bam, bam, df dx. Sometimes in mathematics there's a nothing and then we put in something. This one is okay because dg over dg is 1. So nothing I did wrong. But what is this? Do you see this one somewhere? Yeah, I see this one right here. What did I write? That is the derivative of this one. So that's a derivative of g function, right? I'm talking about this one. And then what about this? Did you see this one? dg dx. That is times. That's the derivative of the g function. So we're gonna write it derivative of a g function input is x. So if I clarify this, I can write as g function, but that input is x, right? So I just write it clearly, same thing. And that's the answer. So how we, it's not answer, it is how we prove. And how we figure this one out? Just basically, you take a derivative of outside function because that was the input, right? And then this is your derivative of an inside function. And then what do? Multiply each other. So this rule, we call it the chain rule. I think because you just chain like a multiply. So if you have 3 functions, then you're gonna multiply 1 to 3 functions. If it's a 4 function combined, then it's gonna be 4. Yeah. This one, actually, you see that you have to use product rule and then chain rule. So it's gonna be a little bit more difficult. So let's look at some idea here. So this is the definition that your book shows. For me, it is a good definition, but it's not fun for me to explain. So they use this term. But if it's confusing you, I had same thing. I just change to g function and f function that we've been using it. Because I didn't want to change to y and another z. We don't have, right? So it's the same thing, and then that is the same definition. So just remember that. And then I will show you how we're going to take a derivative. So let's look at appetizer. So now staring at it, and you need to see that there are 2 functions. I see there's a function 1 outside, function inside. So you have to look this one as your function e to the something. What was our function e to the? I don't want to use actually x because it confused with this one. So I'm going to use e to the star. Okay, I'm going to use star as x. Then what is the derivative? So let's put input is a star. Then it's going to be e to the x, e to the star. So here said take a derivative and then keep your function inside. That means just take a derivative of the if function and then whatever circle, that's the star, keep it. So I'm going to take a derivative e to the circle, right? That star, which is 3x. Okay, so I took the derivative of outside times, now take a derivative of inside, which will be 3. Answer. You have to practice. This one looks easy, but it's confusing. So now let's look at next one. Do you see 2 functions? Do you see big function? I see exponential function. Something like, I will just use x, which I don't prefer. So x to the 2020. That's the outside function. Inside function is square root of x equal minus 1. And I can call this one the g. This one is a function, outside function, inside function. Then I'm going to take a derivative. So if I take a derivative, that will be 2020x to the 2019. But you have to be careful. This x is for this function, but this function has x is your g function. So that means 2020, your function is square root of x minus 1 and 2019. So basically, you just took the derivative of this function. This number, put it down, and then copy the circle because that's your whole g function, and then power 1 more. So I took the derivative outside, and that is 2020 square root of x minus 1, 2019. So now we need to take a derivative inside, which is square root of x minus 1. If we take a derivative, we can use x to the 1 over 2 as a power rule. So 1 over 2 x to the negative 1 over 2, 1 goes away. So that becomes 1 over 2 square root of x. You will get familiar soon because it will be coming out often. So now I'm going to multiply 1 over 2 square root of x, which I can just put on as a denominator, 2 square root of x. Then after this one, we can reduce this one as 1, 10, 10. And then square root of x, you can actually rationalize. So you can put square root of x and then rest of the square root of x minus 1 to the, over x. Hard to see, right? I multiply square root of x and square root of x. But you see that you cannot combine them. So you can write that one. Or probably that could be answered just before. Yeah, you may not be able to rationalize depending on try, okay? Sometimes I feel like I have to go all the way. Now there are 2 in-class activities, so I want you to try and then compare with me. Hey class, how did it go? So did you see that calculus is beautiful? All those algebra and math you learn comes into calculus, right? It's so fun when you get it. So first one, that was, I saw the outside function 2 to the m. And then I not use this one, and the inside function, if I set as m, that's x cubed. So I took the derivative, that will be natural log 2 to the itself, because this one becomes natural log 2 and then 2m to the n. And then next one, you just take the derivative and put it in. So make sure there's a multiplication. But I want you to, I'm pretty sure you want me to explain b. So did you notice that the circle here, for me, without this, same as other one. So I have a 1 function and 2 function. And then multiply this one. So I see the form here. And how we're gonna take a derivative, we have to use a product rule. So product rule, I learned like this way. Take a derivative first one, and then leave, copy down second factor, plus don't touch anything, first one, and then take a derivative of a second. So that's at f prime times g plus f times g prime. That's how I learned with the shape. So I want you to see, first I took the derivative of first function, which is 1, and then I copy down. Plus, careful, next one I copy down, so which is x, and then I took the derivative of this one, which is above. Or if you see this one, I actually simplify really nicely. So look at this one, I multiply, I have this function x here, and then I took the derivative, which is a power comes down, and then inside itself. After this one, I'm going to have taking derivative of this one will be 1 over 2 square root of x. So cancel out 2, and then I rationalize it. That made it really nicely canceling out this. So I have 10 square root of x, and then rest will be my function. So I notice, this one and this one I can factor out by 2019. So I took factor out 2019, and I see very nice mistake here because I was excited. So I said there should be one of them left, right? So square root of x minus 1. Good mistake, I'm double checking. Square root of x minus 1, because one of this one left, and then plus this one, all of them pull it out, so I have this one left. So that means I can even simplify more. And times, if I organize, that's going to be one more, 10, 11 square root of x minus 1. That's my answer. I don't think I can go any further. So that's your derivative. But as you see, actually, you have to simplify all the way. It turned out pretty nicely. Yeah. So that's kind of an answer. You have to put it on the homework too. So good luck. So now I'm going to explain more about those kind of questions on main dish. So keep follow me. Continue our main dish. So main dish also, we are going to just build the function a little bit more fun. So first of all, when you look at this one, try to circle how many functions are combined. So I see polynomial inside, and then recall function outside. And this one also, it's a little bit hard to see, but do you see that there's a one function, and then there's another function. In this case, you could choose this way too. Probably you can rewrite it, x squared plus x to the 4, and then to the negative 2. That's another way you could approach, and then 1 and 2, whichever you prefer. Okay, and last one, this one, whole thing. I know there's an e, but still you can do with this way, then this way, and then oh, I see another hard one right here. This one eventually have 3 functions combined. So I see there's a function of a power. Is it? Try. Yeah, I think so. So let's look at taking derivative of each. So this one, as I said, it's like a peeling onions. So we are going to take a derivative of a f function and then keep the g function inside, then g function, take a derivative. So look at the pattern again. I'm not gonna do anything of this part, just take a derivative square root of whatever. So we have square root of m. What is the derivative? It will be 1 over 2 square root of m. I want you to keep play because you will see that eventually m to the 1 over 2 comes down, and then negative 1 over 2 becomes the square root of m. Okay, I'm not going to explain much anymore. So here I get 1 over 2 square root of, copy rest of them, 2x cubed plus 6x minus 7. So I'm done with my derivative of this part, times, so do you see the derivative of that part? 1 over 2 square root. Then now let's take a derivative of inside function. Inside function, so carefully, that becomes a 6x squared plus 6 Yeah, that's what I got. Then, of course, we cannot stop here. We have to rationalize it. No, not rationalize, hopefully not. And we have to organize it. So 6 I'm gonna pull out, and the inside have x squared plus 1 over 2 square root of 2x cubed plus 6x minus 7. So I have to reduce this one, which should be the answer. Let's look at B. And B, I like to actually compare two different ways. So one of them, I can actually approach x squared plus x to the fourth to the negative 2 power. And then another way is I can just approach as written this way. So let's see if we can take a derivative. So if I take a derivative, make sure that where all the functions are. So I see outside function is something to the negative 2, and then inside function is going to be x squared plus x to the fourth power. So okay, I see this function to the negative 2. As you see, it's going to use a power rule. So let's take a derivative. If I take a derivative this one, I get negative 2t to the negative 3. So I'm gonna write it everything with negative 2. And then now, careful, what is t? T is the function inside. So x squared plus x to the fourth to the negative 3. So I finish the function of an outside function, and the inside function multiply and then take a derivative. That will be 2x plus 4x cubed. But we are not right answer this way. We like to actually write it all out. So I'm going to carefully rewrite it. This is going to be negative 2. Look at here. Do you see the factor? 2x inside 1 plus 2x squared over denominator. I have x squared plus x to the fourth to the third power. Are you done? I don't think we are actually done. We have to go simplify a little bit more. That will be negative 4. And then did you notice there will be more x will come out? Here x squared 1 plus x squared. And cube, do you see that? If you distribute, you get that one. So if I rewrite denominator, that becomes x to the 6th, 1 plus x squared to the third. So there's a 1x, 6x, one of them cancel out there. I will have x to the 5, 1 plus x squared cube. And then top, I will have, since the x is gone, I will have a 1 plus 2x squared. Do you remember I said keep practice? Just the algebra pops up like this. So just keep trying and then see where you can end. So now I'm going to try with different rule. So if I use this one as a quotient rule, then you need to see that one of my outside function 1 over t squared, 1 over circle square, 1 over t squared is the outside function. Inside function is the same as this one. So t is equal to x squared plus x to the fourth. Okay, we can write this one as probably g function or f function. Okay, so if you see this one goes into here, that goes here, here goes here. Okay, so you see the puzzle. So if I take a derivative of this function using the quotient rule, and then you don't like quotient rule, sometimes handy. This is going to be square, so t to the 4. Take a derivative of 1 is 0. 0 times leave it minus leave it times take a derivative. Then this one is 0. I have a negative 2t over t to the 4 makes negative 2t to the third. T cancel out. So derivative of first one become negative 2. Denominator t is x squared plus x to the fourth cube. Okay, I just copy in inside times. So take a derivative of this one. Just do with me about 5 and you will see the pattern. So take a derivative, that will be 2x plus 4x cubed. And once you see here, you see same pattern right here. So, Yona, I don't like that one. That's actually your preference. Sometimes it's easier to do this one because it could be shorter. Sometimes it's easier to do this one because you don't have to deal with negative powers. And it actually cancels out sometimes nicer in this form too. So, as you see this one is exactly same here. And then you can continue. Okay, let's look at C. Now I need to see how far we have to take a derivative and then when we stop. So let's try this one. I see outside function as a square root of t function. Okay. I see inside function look like polynomial. And then, yeah, I think that's it because they are all the additions. So we can just take derivative one by one. And when you take a derivative, this guy probably have to be a little bit careful later. So this case probably easier. They are 1, 3, 3. Okay, just let's do it. So outside and the inside function t is resolved inside circle. So let's take a derivative. As you saw it, this one, do you guys now remember what's derivative? 1 over 2 square root of x of t. So I'm going to take a derivative 1 over 2 and copy rest of them inside 2. I wonder if I should write it a little bit nice way. Oh, not yet, because we have to take a derivative, right? This one I will change for you because it will be easier. 1 over 5x and minus 7. Okay, so I'm done with derivative outside. And let's take a derivative inside carefully. So look at what your function is. This one is a power function, so we're just gonna use a power function rule. 1 over 3, I like parentheses. So x negative 4 over 3 plus, I can organize later. Next one, careful. E function, how do we take a derivative? This one, actually, there's some chain rule here. So how we take a derivative? As we saw, we take a derivative of e to the t, which is e to the t, which is 1 over 5x, and then take a derivative of t, which is negative 1 over 5. So that was the derivative of the middle part, the 1, 2, 3 terms, and the negative 7 is a 0. I'll write it just for today. Then I want to see if I can go any further to organize. It's not going to look nice. I can already feel it. Yeah, numerator will be negative 2 over 3 square root of, that's going to be x to the 4th power we cube, plus, next one, negative 1 over 5, and e to the negative 1 over 5x, just put it down, over, denominator I will just copy, 2 times square root of 2x. Oh, okay. I think we should just keep it negative. Negative 1/3 plus e to the negative 1 over 5x, because that looks longer and bigger one. So I wonder if you should just keep the top two. Yeah, you could just keep the top if you organize it. I will help you. Negative 2 over 3 x to the negative 4 over 3 plus e to the negative 1 over 5 e to the negative 1/5 x. And sometimes that will take the answer. This one is without the negative power. This one is with the negative power. So I want to see what the answer will look like in the future. So, and the denominator is the same. So that's how it's gonna look. And yeah, that's it. So there are in-class activities, and I want you to try some of them and then come back with me. Okay, how did your in-class activity go? So mine went this way, and if you look at first one, make sure you circle and then just staring at it, take a derivative. So I took a derivative over the first part, and then inside circle, I took the derivative here. So that's what I got after I organized. Also learn how to organize for your Wiley plus answer. And next one, this one has 3 circles, and there's a function of a chain rule and then product rule. So I just break it down, you to understand how do we apply our product rule. Take a derivative and then leave it and leave it and take a derivative. So I took the derivative of a circle and then just copy down the second part of the factor plus just copy down and then take a derivative. So it's not actually hard if you once get used to the system. It takes about 4 or 5 questions. So I took the derivative of this one, which has a chain rule. So you just take the derivative 2 to the t, which is a natural of 2 to the t, which is 5x, and then take a derivative of 5x is 5. So I took the derivative of this part, and then I say copy. So I copied it. Plus, next one is you don't touch anything. So first circle, I'm going to copy, and then take a derivative of the last circle, which is 2x. Then you have to factor it out. So this is 2 to the 5x, 2 to the 5x. I factor it out, and then rest of them, I copied it. So it's going to be 5x squared natural log 2 plus 2x. Why did I factor out x? Sometimes we do, sometimes we don't, so that you can separate them with their nice functions. This one's exponent, this one is going to be some sort of polynomials, right? So that's what sometimes we put it this way. So that's mine, and there's a now C waiting, and let's see that you get that one. Just how far, about a few steps with messy algebra. Good luck. Okay, so this one after I tried, I'm okay probably if you stop here, but I'm still probably have to go all the way without the fraction over fraction. So I made a common denominator, and then that became, oh, the mistake again, 24. Yeah, that has to be 24. And because the 12 times 2 is 24, and then rest of the function goes to the top, and then denominator is the same as this one. So I just organized some powers, and here basically I factored out by 12, and then 1 over 12 over 2 over 1 is 1 over 24, so I kept here, and the rest of it. So that's what I got. Getting harder, right? So keep playing, and now we have some dessert left. Okay, class, we are on dessert, so keep practice with me, and let's try to see how many combined functions do you see here. So try to see what are the functions you see. I see big picture of t to the 7 as a power function. And then I see another function here, like this, that's going to rewrite it, and then I see another function inside. So let's see what I see. 3 minus 3, 2, it's going to be just a t because it's a circle, and then last one, can copy. I don't know why I'm saying that. Okay, I'm thinking too much. So if you take a derivative of this one, that's going to be 7t and then 6 power. So look at here. T is the circle right below, so you are going to copy down. So I'm taking derivative outside, that becomes 7, and then copy down 3 minus e to the 2 square root of x, and then that becomes 6. Do you see the same pattern? 7t to the 6 power, and then now you have to take a derivative of this one. Then this t is not same as this t. This t is just a copy down from previous one, so take a derivative. 3 becomes 0, negative e to the t is e to the t. So times negative, since I'm multiplying, I'm going to put parentheses so that it doesn't look like subtraction. E to the, what was a t? That was inside the circle. I'm going to copy. Then another times, we are going to take a derivative. We've done this one many times. Do you remember? That becomes 1 over 2 square root of x, and then I have 2 numerator. So that becomes 1 over square root of x. So all we need to do is let's organize if I can write it better. So square root of x comes down, and then rest of them I have minus 7, 3 minus e to the 2 to the x, and then 6 power multiplying e to the 2 square root of x. So what I did, I pulled out this negative and this 7, wrote it here, then do you see next factor, I copy down, then next factor, I copy down, next factor, the denominator. So that's my answer. I don't see anything I can simplify more. Can I combine this? No, you have to do 6 power. Just think about foiling 6 power. Would you want to do it? No, so we're going to keep it and then write it this way. Of course, it's nicer to put negative 7 and this power in the front. That will be a little bit better form. Okay, so now, before we do B, I want you to also circle and see how many functions are combined, and then compare with me while I'm removing the board. This is the dessert part. So how many circles did you find? I found 4. Okay, I found 1, which is the square root of t function. 2, a little bit hard to see, 2 plus e to the t function. So I see another circle and another circle. So I see total 4. And then after that, I see square root of t, another function. You see that? And then inside, I have x to the 4th plus 5. Okay, so let's try to find the derivative one by one. So let's just focusing on very last outer circle. So if I want to take a derivative, we already seen this one many times. That means 1 over 2 square root of t, just copy whatever inside circle, everything. So 1 over 2 square root of, copy everything, 2 plus e to the square root of x to the 4th plus 5. Now times, we're going to multiply 4 times. Next one, take a derivative of this one. What do you get? 2 becomes 0, and then e to the t, so which is e to the whatever previous function. We are going to copy everything. So times e to the t was this guy, or this guy if you hard to see, square root of x to the 4th plus 5 times. Next one, we see this one now a lot, right? Gets better. So if I take a derivative over this guy, I'm going to have 1 over 2 square root of, copy down, x to the 4th plus 5. Then last one, if I take a derivative for x to the 3rd power, and then 5 becomes 0. So times 4x to the 3rd power. Okay, of course we have to organize. So let's see if we have a way to organize nicely. Then all multiplication. So where are going to be denominator? This is a denominator 2 square root of 2 plus e to the square root of x to the 4th plus 5. And then, so I'm done with this term. This one will be numerator, e to the square root of x to the 4th plus 5. This will be denominator, so I'm going to pull out 2. So that's going to be 2 times 2, and then times square root of x to the 4th plus 5. I don't think we can combine this one, so this one, and then that will go to the numerator, 4x to the cube. Now, what I see, we can at least reduce one part, and then rest one will be answer. E to the square root of x to the 4th plus 5 over, and square root of, I'll write this one first, just a little nicer, 5, and square root of 2 plus e, square root of x to the 4th plus 5. Now, can I put them together inside? Yeah, I think you can put it and then put as a parenthesis inside. But I kind of like it separately this way for now, and then that's the answer. Yeah, not easy, right? So there are now some appetizer part of the in-class, these are part of the in-class activities. There are some 4 questions I kind of built up by like easiest and then a little bit hard and hard. So try those one and that will be it. So good job. Class, last those are 4 questions. How did it go? It wasn't easy, right? Just pause the video and then compare my work. So you can also follow some of them. Once you keep playing, as I said 5-6 times, you will see the pattern. You will do actually mentally like what I did earlier. So the answer, all I circle with a red color and then compare them. And also if you are confused how I take the derivative, I kind of will put those marks that this time to this, and then since this one's 4 circles, I have to have 1, 2, 3, 4 circles. So just carefully look at my algebra. I try to put the position a little look nicer. So this one was a numerator, this one's a numerator, so I just put in numerator, and the rest one is a denominator, which I just put it in, just a messy number, but you can do it. So after you do, just give me some reactions how you did, okay? Thank you.